All right, everybody. Quick video for the first task for next week. I'm just recording this a week ahead. So what you've got, your tab resize, I've put that there. If you still don't have that Chrome extension, obviously I do. I really do like it when I'm doing these types of activities. I think it'd work for you guys. You're getting the same rubric as you've gotten before. You have a slideshow about water quality and a note to fill in about water quality. So don't forget, these count for marks, and all this stuff will be on the test, which will be next or the week after. So you need to have this stuff done. Okay, so water quality in general. There's different ways that we can measure water quality, and this slideshow is going to kind of take you through some of those, as well as add some videos for you to watch to kind of think about water quality. So the first way that we can look at water quality is to look at how much bacterial populations are growing in the water. So if the bacterial content goes up too high, it can be an issue. So if you think about sometimes in the summer at the sandbanks, you'll hear that the beaches are posted and they're closed. And that's because of high bacterial counts in the water that can cause ear and intestinal infections. So that's one way that we can measure the quality of water, is to think about how much bacteria is in it. And just watch the little video that goes with that. Another way to think about the quality of water is to think about how much dissolved oxygen is in the water. So what happens when dissolved oxygen drops is organisms will die. So why would that be? Because organisms in the water are still using the oxygen, right? So for example, when you've got the highest level of dissolved oxygen, what happens to the animals? They're thriving, and you'll see a bunch of varied populations. As the water levels begin to drop, you'll eventually get to a level where there's going to be few invertebrates that will actually survive. And you'll see sort of the middle area. Some invertebrates are going to survive, so things like worms and freshwater shrimp, and up above, insects start to disappear like mayflies and beetles. So again, as you have more dissolved oxygen, which the animals need for respiration, then you are going to have better populations of animals in the water. And as it goes lower, you're going to have not as good a population. So that's another way. So we've got first bacterial. We can measure water quality by bacteria. We can measure water quality by oxygen levels. How else can we? We can look at the acidity of the water. So the acidity measures the amount of acid in the water. So most aquatic ecosystems prefer a neutral solution. And most fish are going to die when the pH drops below 4.5, which means that it is getting more acidic. So the more acidic something gets, the harder it's going to be. But really, they want to stay at that sort of neutral range of 7, around 7, to sort of be optimal, I guess, and be more of a neutral solution. So watch that one. What else can we look at? We can look at the amount of phosphorus and nitrogen that's in the water. So things like fertilizers are used on fields and lawns, and then they get washed into the water. What will they do? They can promote the growth of aquatic plants such as algae, and it can start to make the water appear green and slimy. So there's a really good video there you guys will like. As excessive algae dies, it uses up the oxygen in the water to decompose, and then it reduces the available oxygen to aquatic organisms. So if you have high levels of phosphorus and nitrogen, then it's going to create excessive algae, and then as that dies up, it's going to start to use up the oxygen that's in the water. And if you think back to here, what happens when the oxygen waters decrease? It's going to be a problem for the living things there. Okay, heavy metals. So what are examples of heavy metals? So things like mercury, lead from batteries and pesticides. And what happens? They get absorbed by algae and bacteria, and then they get eaten by larger animals, and the heavy metals build up in the organism's tissue. So organisms high on the food chain accumulate high levels of these toxic materials, and this process is called biomagnification or bioaccumulation. So the idea would be that as an organism that's higher up in sort of the food chain or the food web consumes multiple organisms that would have these heavy metals in them, then eventually they're consuming a lot more heavy metals over time. So it begins to magnify sort of how much of that toxic substance is actually in the organisms that are at the top of the food chain. So what can happen here? It can cause immune system disorders, cancer, sterility, and there's a good little video there about that one. So water quality in general, things that we would look at: bacterial populations, oxygen levels, the acidity of the water, the phosphorus and the nitrogen that's coming out of fertilizers, and things like heavy metals. So your note for this one, let's do our split screen. In your note for this one, you are going to go through and fill in the information about the issues maybe that pop up with bacterial populations, oxygen levels, acidity, phosphorus, nitrogen, and heavy metals. So you're just going to kind of fill in the blank and turn that one into me. But make sure that you do watch the videos. You may have to hit present for them to play correctly, and turn that in when you're finished.